So, we talked about rational exponents yesterday and the day before, maybe even the day before that. Tell me what a rational exponent is. Somebody, please. Please. What's a rational exponent? Okay. Okay, I can turn it. It can be written as a fraction. That's what I was looking for. Fraction is the key word there. So we talked about things like x to the 2/3, right? And then we changed the form of that. What does that look like when you change the form? What number? What's the root? What number goes? 3 and then 2 here. Okay? This is where we talked about the sunshine stuff, right? All right, so we're going to talk about some properties when it's in this form, and then we're going to talk about some properties when it's in this form. If you rewind and think back to the beginning of chapter 2, there were 7 exponent properties. Do y'all remember those? I think, did we make a little foldable or something? No? Okay. I just gave them to you. Y'all got shafted. Sorry. Yeah, we made them last year. So it was those 7 properties of exponents that say, if you're multiplying something that has the same base, what do you do with the exponents? You add them. Remember these properties? Well, half of this section deals with using those same properties, but using them if the exponents are fractions instead of whole numbers. So in other words, the property is the same here if it looks like this. I'm just showing you examples. I'm just showing you some examples. This is just what you do with what does it? If you have this, then you add the exponents. So if I change it to a fraction, the property is still the same. I still do the same thing. I still add the exponents. The problem is now adding fractions, right? So if you get out your calculator, and if you need one, there are a few on my desk. I still have them. There's one here too if anybody needs them. I'm gonna show you how to easily work with fractions on these calculators. Take out your calculator. Oh, I didn't open my calculator up. I have way too many tabs open. And let's add a half and a third on the calculator. Have I shown y'all this before? No? Okay. When you put fractions in a calculator, you have to put them in parentheses always. So if you do parenthesis 1 divided by 2, because divided by is how you indicate the fraction, right? Plus 1 divided by 3. That's the division sign. Hit enter. Now, I want it as a fraction, right? Press math. Enter. Enter. Okay? Remember, when you add fractions, you got to go in and find a common denominator, combine numerator, simplify. This makes it easy for you, okay? So, parentheses, add them, and then math, enter, enter. Okay? No, but you do have a fraction button on yours, and I'll show you. I'll show you in just a little bit how you do it. But you can do yours too. All right, questions about that? All right, so quickly I'm going to run through these properties. This gave me x to the what? What was it? 5, 6. What if instead of multiplying, what if I was dividing? What would I then do? You subtract. So subtract those exponents and tell me what you get. It's the same thing. The only difference is they're fractions instead of whole numbers. What is it? 1/6. What if we did this? You multiply. What do you get? All right. What if I did that? Yeah, good job, Cameron. Flip it and make it positive. Negative exponent, right? And other than, yeah, that's it. No. Y'all, I can't eat. I'm going to use numbers instead of variables. Treat them just like you would a variable, okay? Let's say I have I want you to simplify this as much as you can. As much as you can. Huh? You do, because you're multiplying inside, you do have to distribute. So this becomes, yeah, because the bases are different here, so you can't add the exponents. Okay? So 1/3 times 3 is what? 1. And 1/4 times 3 is? Come on, what is it? What is 3 times 1/4? 3/4. That's all you can do with it. Okay? Now I'm going to give you a hint. When you're multiplying or dividing, and this is only true when you multiply or divide, not when you add or subtract. When you multiply or divide, if the bases are the same, combine the exponents. Exponents. But if the exponents are the same, exponents. You can combine the base. Okay? Never both, though. Don't do both of these. I am. The blue circle of death.
What?
If bases are the same, combine the exponents. If exponents are the same, combine the bases. If those situations arise. Yep, but never both. Never both. And I'll give you a second to copy that before we... All right, I'm going to put several examples up here, and I want you to think about them for just a second and tell me what we need to do. Here's the first one. What do you notice? What's the same? The bases. What?
Is that bad?
So we've established that the bases are the same, so we should combine the exponents. So add them. Oh, I shouldn't have told you that. I should let you tell me. So keep the base, add the exponents. What's 1/2 plus 1/4? 3/4.
3/4. Oh.
Gotta do it on a calculator. How about this one? Distribute, because nothing's the same right now, right? I'm going to distribute through. So when I distribute, I need to multiply the exponent. 1/2 times 2 is 1. 1/3 times 2 is 2/3. Are the bases the same? Are the exponents the same? It's done. How about this one?
Combine this exponent. The bases.
Combine the bases this time. Why, John? The exponents are the same this time. So when you do this, you'll combine the bases, and when I say combine, whatever this operation is, what's 4 times 3? 12. It's got the same exponent. Can I do anything else?
No.
You sure?
Bueno, yeah.
I can multiply them because I got a power to a power. What's 1/5, or what's 5 times negative 1/5? -1. And yes, McKinley, you do have to flip it since it's a -1.
All right, let's get it first. Not a lot.
I got 2 more examples.
Not a lot, is it?
No.
How much? What's on this?
3, 6, 9, 12.
Oh, my Lord. Now, so that's only 4 problems. Oh, my Lord, baby. Wow. Hold on, what I say?
Try this one.
What I say?
Nothing. Quick. All right, what do I do? What's the same? The base is the same, so subtract the exponents. However, I do not see an exponent on the top one. It's 1. So what is 1 minus 1/3?
3.
2/3.
I know what they're doing. I know what they're doing. Wait a second. I know what they're doing. Wait a second. They're taking.
Thomas, this is the last one. David, think about it before you blurt it out, okay?
Bobby.
What can I do? Combine the bases since the exponents are the same. What's 42 divided by 6? 7. Apparently you don't have to be so excited about it. Power to a power means or multiply. So 1/3 times 2 is, I might have told a little story.
Oh.
Just because you're going to encounter one like this. If both are the same, what do? Pick one. Don't do both. Okay? Either do 25 to the 1/2 or do 5 to the first power. Don't do both. This is the same thing. Power 1/2 is a square root. Square root of 25 is 5. They give you the same thing, but you can't do both. Don't say it's 25 to the 1. Okay?